we studied about last time we studied about the centripetal and centrifugal force. So with that we finish off with that chapter. I had already given you the homework and asked you to do some of the questions in your copies. Today you will have to do all the questions and numericals. You have to practice all of them, but only those numericals and the questions from the exercises you will be doing, which I had given as an homework. Okay. Today we will be starting with the second chapter. Start with the second chapter. So you please keep your video off. The second chapter is your work, energy and power. If you have any problem in the first chapter, the group is open and it will remain open till 8 o'clock in the evening. And during that time you can convey your problems. And if the time permits, then we can take up the problems one by one towards the end. So we'll start with the second chapter, that is work, energy and power. You can go through later on. I'll use the base of that note only to explain you the things. So we start with the work. Now, work is a very common term which we are using every day. Okay, or whatever activity we are doing, we are using this word work. But when we are talking about the work in scientific term, and especially in case of physics, so we can classify the work into two categories. One is your physical work, the other is your mental work. Now mental work is like you are studying or you are reading something or you are thinking. Just now some of you say, yes, I'm thinking. Okay, yes, definitely you are doing the work, but that work is considered to be as a mental work. Now how to differentiate this mental work and your physical work? As per the definition of work is concerned, your work is said to be done only when the force applied on a body makes the body to move. That is, there is a displacement of the body. So in terms of your physical work, okay, or in terms of physics, if you apply a force and this force causes certain displacement, then you say that work is done or work is said to be done. Now suppose if you are thinking, there might be certain type of mental force which you are applying, but physical force is not there, as well as there is no displacement which can be seen, and therefore the mental work has got no place in physics. So it's only the physical work which is considered in physics. Okay. Now there are various examples over here where you can say that the work is done or work is not done, although you are applying force. Or say, for example, if you are cycling or you are applying force on the paddle, and when you apply force on the paddle gets displaced. Along with it, your it also performs the translational motion, or it moves in a straight line. Or in a simple term, we can say that it gets displaced. So as it gets displaced, so we can say that some work has been done. Similarly, you throw a ball, so you apply a force on the ball, and then you find that the ball goes to certain distance. As the ball moves to certain distance, so it is covering certain displacement, and as a result, we say that our work is done by the ball. Now, suppose if you are applying a force, whatsoever force you apply, but you are unable to displace that wall. So, since you are not able to displace the wall, therefore, no work has been done. So, pushing a wall, for example, here if you see, when we are considering the pushing of the wall, we find that pushing of the wall does not create any work. Okay, so as the work is not been not been placement, so no work has been done. So this was few examples where we are able to see that the work is done or work is not. So you can consider all those examples where you apply the force and there is no displacement. Okay, you can say that work is not done, or those will not come under the category of work. Similarly, in a circular motion, if you are taking, now if you after one complete circle, that means the body rotates and comes back to its initial position, you will find that the work done will be zero, because the displacement is going to be zero. But if you try to find out the work done at certain instance or between certain interval, then definitely some work has been done. Okay, now we start with the next portion, that is movement of the work. Now if we are talking about all these examples of work, how can we make out that the work is done? Force applied dealing with the substance. So one of the factor is the force applied, and the second factor is the displacement produced. Displacement produced and force applied. Now let us take an example to show how the force applied is going to be determining the work done. Now here we have taken two conditions. We have a body A, and okay, and we are applying two forces, F1 and F2, such that the force is greater than force F2. But both the forces are going to displace the body through the same distance S. Okay, so displacement remains same. So more effort has to be applied on A because we are applying force, a greater force, which means that it is using more work, whereas B is requiring less force, so it is consuming less work. So you can say that in the first case, the work done is going to be greater. That is, the work done by F is greater than the work done by F2. So here we have expressed it. Work done by F1 is greater than the work done by F2. That means greater the force, greater is the work done, lesser the force, lesser is the work done, and as a result we find that we can make out that the work done is directly proportional to force applied. Now we come to the next case. In the next portion, we find, or the next factor which affects the work done is the displacement produced by the force. Okay. So let us see how the work done is depending upon the displacement produced. Now here again, we are taking two cases, A and B. B I have forgotten to mention it in the diagram. You can mark them as B. So this will be considered as B. This one is going to be B. Okay. Now, what we do? Here the force applied is going to be same on both of them. But the displacement caused in A, that is S1, is going to be less as compared to the displacement caused by B. Means we are applying the force on the same, on the two bodies, and one is getting displaced by a lesser distance and the other is getting displaced by a greater distance. So the work done, those which is getting displaced by a lesser distance, you have to apply lesser effort, so you can say that the work done is less. Whereas where it is getting displaced by a greater distance, so you can say that you are applying, rather the work done in the second case is going to be more. So here we find that if the displacement is less, the work done is less. The displacement is more, the work done is more. As a result, we can say that the work done is directly proportional to the displacement. So what we have got, we have seen that the work done is directly proportional to the displacement, and the work done is directly proportional work done is directly proportional to displacement, force, as well as work done is directly proportional to displacement. So if we combine these two, we get it as work done can be expressed as W is equal to F into S. So work done will be your F into S, or work done can be written as force into the displacement of the point of application of force in the direction of force applied. Now here one thing has to be mentioned, that the force with the displacement which is taking place, that is in the direction of the force applied. So in both the diagrams, if you try to see, this diagram. If you see, the displacement is taking place in the direction of the force, where, or it is this diagram, displacement is taking place in the direction of force. So in both the cases, we find that the displacement is going to take place in the direction of force. So now work can be defined as the amount of work done by a force is equal to the product of the force and the displacement of the point of application of force in the direction of force. That means if the direction of force is zero, the work done will be zero. Okay. So this was a basic definition. Definition of the work done. Now we move to the next topic. I hope this is clear to all of you. You can write down. Now we move to the next portion, that is your expression of work. How to increase that bandwidth? I'm not very well versed with this technical portions. The next portion I will try to. So now we move to the next portion, that is the expression of work. Now actually when we are mathematically expressing the work, we express it as W is equal to Fs cos theta. Now what is this cos theta and why we express it as Fs cos theta? That is what we are going to study now. That work is said to be done when you are applying a force and the force is causing the displacement in the direction of application of force. That means if you are applying a force towards the left side, the body should also move towards the left. And if you are applying a force towards the right side, the body should move towards the right, or up or down, or whatever be the direction in the corresponding direction. But it is not always that you apply the force and the body is going to move down in the same direction. Now what I mean to say by saying this, what I mean to by saying this, this simply means that if I am applying the force towards this, the body has to displace in this same direction. But it is not necessary that always we are applying a force in this direction. The body may be moving diagonal to it, or may be moving at certain angle to it. All right. So how to do in that case, or what will be happening in that case? So we come to that portion. case, we have two cases. One is that by finding out the component of displacement of body in the direction of force, and second is by finding out the component of force in the direction of displacement. Now what does this mean? I take the first case where it is to find out the work done by finding out the component of displacement of body in the direction of force. Now for this, what we have considered a body on which a force F is applied, and this body moves along an inclined plane, that is AC. Alright, force has been applied in the direction AB and the body moves along AC. If you observe, here is the force applied and the body is moving along AC. This is the C part. Okay. So now this is going to be moving through an angle theta. So the force applied over here is F. The displacement which is taking place, that is AC. Now according to the definition of work, that is a mathematical expression of work, we can say that work done is equal to force into displacement of the point of force in the direction of force applied. Okay, so what does it mean? It simply means that here if I have to find out the work done by this force F, if I have to find out the work done by the force F, then this will be the product of this force and the displacement in the direction of force, that is along AB. And therefore, if you try to observe, you will find that W is equal to F into AB. But if you see it in the diagram, we do not know AB because the displacement S is taking place along AC. So what we have to do is, we have to find out this AC along this direction, that is along this AB. Now, in this case, if you try to remember, this is forming a right angle triangle. ABC is your right angle triangle. Therefore, if we try to express theta, this could be expressed as cos theta. And cos theta, we all know that it is based upon hypotenuse. That is AB upon AC. And therefore, from there, if you try to calculate, you will get AB as AC cos theta. And since the value of AC is S, so you get it as S cos theta. So here I have expressed it. Cos theta is equal to AB by AC. AB is equal to AC cos theta. But AC is equal to S, and therefore AB is equal to S cos theta. This part is what we call it as resolving or finding the component displacement in the direction of force applied, which means that S cos theta basically represents the displacement in the direction of force. Force is also in this direction, displacement is. What we have done is try to find out displacement in the direction of force. So now we try to apply it to the formula. Now putting the value of AB in equation 1, we get it as W is equal to F into S cos theta, and this is equal to Fs cos theta. So this is how we are getting the expression for the work done as Fs cos theta. Now this is a standard expression. Okay, what we are trying to derive over here is a standard expression, and what we have studied earlier, that is W is equal to F into S, that is a special case. We'll come to that also when we finish off this derivation. Now this was the first part where we were trying to express the displacement in the direction of force applied. Now, the second portion says we can also find out the work done by finding out the component of force along the displacement. Earlier it was displacement along the force, and now it is force along the displacement, which means that now we are going to express force in terms of the displacement, in the direction of displacement. So again, the same example has been taken. Okay, so here what we find that PA is representing the force F. On applying the force, the body gets displaced through an angle theta by the distance S. Okay, now, so if we apply the formula, it is force into displacement. Force is represented by, now in this case, now force into displacement means force in the direction of displacement. Now force in the direction of displacement, if you try to observe, we have we are having the displacement along this direction. So what we have to do is we have to express the force also. This is your direction of displacement. Although the direction of force is in this direction, but we have to express this force along the direction of displacement, which means it should be expressed in this direction. Okay, so now if you try to see, this will become equal to NA, is representing by NA, and your displacement is AC. So NA into AC. Now let's come to triangle formation. So this is the right angle triangle which has been formed over here. This is your right angle triangle which has been formed. Now we all know that we have extended this over this side and a perpendicular has been dropped, and as a result, we observe that this angle will be equal to, angle theta will be equal to angle PAN, which is equal to your vertically opposite angle. Here I have written angle BAC is equal to angle PAN, that is in triangle PAN, angle PAN will be equal to theta degree. Now we come to the right angle part. Now since we require AN, so the trigonometric ratio which can be used over here is again your cos theta. Now therefore your cos theta here will be equal to base, that is AN, upon hypotenuse, that is PA. So NA upon PA, that will give you NA is equal to PA cos theta, and this is equal to F cos theta. Now, if you observe, this F cos theta is basically the resolving or finding the component of force along the displacement. So here we have expressed the force in the direction of displacement. So as a result, when you substitute it into its value, we will find that W is equal to F cos theta into S, which is again equal to F. So here you have Fs cos theta. Now from the above discussion, we can make out the factors or how the work done can be calculated, or on the factors on which the work is going to be based. There are three major things. One is your magnitude of the force, that is your F. The second is your displacement, is, and the third is the cosine of the angle theta, that is where theta represents the angle between the force applied and the displacement taking place. Okay, so these are the three factors on which the work done can be calculated in terms of physics. Three cases. And before we move to the special cases, so I hope this is clear to all of you up till here. If you have any question, you can ask. Question is given. No. In this case, if you observe, when we are expressing it, either the force in the direction of your displacement or displacement in the direction of force. If you use sine theta, the component is not going to be in the same direction, and that is why your work done is always cos theta. Somebody, Kritin, you asked, is work done in drawing from a well using a pulley in drawing water? See, when you are drawing this, we will come to the next case when we are dealing with the special cases. Now, in this case, we find that there are two types of work done. One is work done by the gravity, and the other is the work you are doing. Okay. Now, when you are pulling, so basically your angle is going to be different, and depending upon that angle, you will be able to do the work on the well. Okay, because your force is going to be now if it is 90-degree, definitely the work done will become zero. So, work done will be your maximum, and in case of 90-degree, the work done will become zero, because cos 90 will be equal to zero in that case. But if you have got some other angle, then you can say, for example, if you are directly pulling the bucket without using a pulley, in that case your force will be in upward direction, your displacement will also be in upward direction. In that case, the work done will be maximum, that is F into A. So Pratami, you asked if the body is moving in the same direction of the force, then cos theta will not be taken into consideration. No, we are actually taking the cos theta also in that case. We'll come to the next one. Here, basically what happens, since the displacement and the force application both are in the same direction, so the angle between them becomes zero, and cos 0 is 1. Therefore, the formula of work becomes your Fs, and that is why it seems to you that, okay, we are not taking the cos 0-degree, but actually we are taking it. But that is why we say that the maximum work is done when the displacement is taking place in the direction of application of force. Anyone else having any question? I have already told that if you try to resolve if you try to resolve the angle, okay, you will only get the cos component of the trigonometric ratio, which can be expressed in the terms of your work done. Okay, and that is why we use cos theta, not sin theta, or any other trigonometric ratio. So is it clear to rest of you? Some of you are talking among yourself also. Formula. Same notes. Now see, uh, if you try to observe, when we are applying the value over here, so this part is your theta, direction of this, that is force, and the direction of displacement in the first case, if you try to observe, they should be same. So force is applied in the direction of AB. Actual displacement is taking place in AC direction. So if we have to uh, show the displacement in the direction of the force applied, then this should be the resolution. That means this line should come over this line, which means that AC will be equal, AC should be in the direction of AB. In simple terms, we can say that we have to find out AB. Now to find out AB, the best suited trigonometric ratio over here, if you observe, which gives us the relation between your AB and AC, is cos theta. If you use cot theta, so that will be, sec theta, somebody was asking. In case of sec theta, if you use, that will be becoming your AC by AB, and in that case, that will be below. So that is why, so if you have to use, it will become your W is equal to Fs1 upon sec theta. Now, instead of going for that, Fs cos theta happens to be more standard way, and that is why we are taking the basic trigonometric ratios. Now, basic trigonometric ratios are your sine, cos, and tan. So here it is the cos theta which can express, or through which you can express AB, and that is why we are taking cos theta. In the second case also, if you try to observe, okay, so F has to be expressed along the displacement. Now in the second case, if you see, the displacement is along this direction, force is along this direction. Now in the second case, the force has to be expressed along the displacement, which means it should be in this direction. Displacement we are not going to change in that case. Now again, in this case also, the basic trigonometric ratio which you can take, so that you can use PA and NA, that is your cos theta only. Okay, if you take sin theta, it will be your Pn upon Pa. So you will not be getting the value in the direction of displacement, and since you are not going to get the resolution in the direction of the displacement, therefore the basic fact will be wrong, and that is why we are going to take this cos theta. I hope it is clear now to all of you. 5 more minutes, so I'll just quickly go through. We have certain special cases. Okay. Now, what somebody was asking, what happens if we are pulling the perpendicularly or 0 degree? Now, we have three basic cases which we are considering, so that the angle between the force applied and displacement. The first case happens to be when theta is equal to 0 degree. When we say that theta is equal to 0 degree, what actually we mean? We simply means that the displacement is taking place in the direction of force applied, or the force is in the direction of displacement. Generally, force is applied and the displacement is going to take place. That will be the way of. So in this case, when you are applying the force in the direction and when the displacement is taking place in the direction of force applied, so theta becomes 0 degree. Okay, if you observe here, the direction force is also in this direction, and the theta, your force is also in this direction, and your displacement is also in the same direction. So the angle between them, if you try to observe, that will be 0 degree. As a result, we find that theta will be 0 degree, so cos theta will be equal to 1, and in that case, the work done will be equal to Fs. So this is the maximum work done when you are applying a force and the displacement is taking place. Just for convenience, we use it as positive. Keep in mind, work is a scalar quantity, and therefore we do not require to mention its unit, direction, magnitude is only required, and therefore we consider it as a positive. Now there are certain examples of the work done in this case. The first is of freely falling body. Now when you are talking about the freely falling body, now we are going to find out the work done by the body, by the gravity on this body. Now, if you are dropping a ball and it is freely falling under the gravity, so the work done is by the gravity. Now, if you try to find out the direction of the force, that is the force of gravity, that will be in downward direction here, if you can see. Now, this force is causing the ball to move down. As a result, the direction of force as well as the direction of the displacement both are in the same, and therefore theta becomes 0 degree. So now here, if the force of gravity is considered to be as mg, okay, and it has been from a height h, then the work done by the gravity on the body, that is equal to mgh. Now there are various terms which are to be used, and it's a bit confusing also. Here you should be very clear that this is the work done by the gravity on the body, okay, which is positive, and the maximum work done is equal to mgh. Okay, the second case, that is your Coulomb. Now Coulomb also, there is a various type of explanations, and there are various questions, so you have to be very clear with the questions. Now here it says that work done by the Coulomb in lifting load. Now keep in mind, while he is lifting the load, so he is trying to apply the force by himself against the gravity. So we are trying to find out the work done by the Coulomb on the load, not by the gravity on the load. So in this case, what happens? The Coulomb will be raising the body, so he will be applying a force in upward direction. Okay. As a result, when he applies the force in upward direction, the load also moves in upward direction. So both of them are going to move in upward direction, and as a result, the angle between them will be 0 degree, and hence cos 0 equal to 1, and hence the maximum work done by the Coulomb to raise the body from a ground to a certain height h will be equal to mgh. Okay, this is the work done by the pulley, okay? It is not the work done by the gravity, okay? So this is all about today. We will be, so one more example we can take. Time is still there. That is your second case. When theta is 90 degree, which means that on application of the force, you find that the angle through which it is going to be moving, that is 90 degree. So here I had given you an explanation. Now cos 90 degree is your 0, and therefore we find that the work done, whatever force you apply, whatever displacement this causes, if the angle between the force applied and the displacement taking place by the body is 90 degree, it will be 0 degree. Okay, that is no work is said to be done in this case. Again, we come back to the pulley one only. Now this is work done by the pulley in walking along the horizontal ground. That is what we are trying to find out by keeping the load on his head. So keep in mind, we are trying to find out the work done when the pulley is walking. So if you can see it in the diagram, so the motion of the pulley is along the ground. The force of gravity which is acting on the body, that is towards the down. As a result, the force and the displacement are, so this is your force, this is your displacement. As a result, we find that they are mutually perpendicular to each other, and hence we observe that the work done in this case will be 0 degree. Not 0 degree, 0. That is, no work is done by the pulley while keeping the load on his head and walking horizontally on the ground. Definitely he will be doing some work against the friction and all those things. Okay. And similarly, when the body is moving in a circular path, that is your horizontal plane, the work done by the centripetal force. Okay. So here also you will find that centripetal force is going to act in this direction, displacement will be in this direction, so the angle is 90 degree, work done will be 0. So these are some of the examples where we find that these are some of the special cases where we find that the work done is equal to 0. So please go through the chapter. Please go through the chapter. I've given the notes. Notes should be written. I hope all of you have written down your previous work. Please keep your work updated. If you do not keep your work updated, you will be having a lot of problems. So keep on updating your work. If you have anything, any problem, then you can post to them and I'll try to explain you. And one day we will be keeping a session. The problem is that you all talk among yourself. If you keep quiet, all of you, one by one, if you try to discuss, then we can discuss one by one your problems also. So this, if you take care, then we can have one session where we can interact personally and clear your doubts. So by this, so I'll be closing now, ending this meeting, and the detail I will be giving you on the group. Notes I have already put, some homework I will give you, and we'll continue with the class whenever we have the another one.